Swayam Prabha. Digital India. Educated India.
Welcome to Mechanics of Materials course. This course in some universities is also called as Strength of Materials, but I find the most appropriate name for this course would have been Mechanics of Deformable Bodies. Here I have used two terms, one is mechanics, the other thing is deformable. Let us understand what do they mean. First, mechanics means the set of principles that govern the displacement of the body. Okay. You would have had a previous course in mechanics called engineering mechanics, where you would have dealt with the mechanics of rigid bodies. In contrast to rigid bodies, what we are going to look up now is deformable bodies. So, let us understand what do you mean by a rigid body. A body is said to be rigid if the distance between any two points in the body does not change due to the application of a force. Okay. In contrast to this, we have what is called as deformable bodies. Wherein a body is said to be deformable if the distance between two points in the body changes due to force. Okay. So, what you would have dealt in a previous courses, you would have assumed the bodies to be rigid, and you would have analyzed the bodies as rigid bodies and related the force and the displacement of the body directly. Vis-a-vis, in this course you are going to assume the body to be deformable, and you are going to analyze the body as a deformable body. Next, let us understand why do you want to relax the assumption of rigidness of the body. Why assume a body as deformable body? Okay. Why do you assume a body as a deformable body and not retain the assumption that the body is a rigid one? The reason is the following. Let us consider a plain two dimensional truss of this geometry, where let us say ABC are hinges and the angle at A is theta and angle at C is also theta. You apply a force like this at B. Now, you can use the force equilibrium equations to determine what are the forces in this members FAB and force in this member FBC from equilibrium equations, right. Essentially, you would have force in the x direction to be 0, wherein let us assume your x and y directions are these, x and y direction are these. Then assuming this to be the positive direction, positive x direction, you will have f b c cos theta minus f a b cos theta to be 0, from where you get that f b c must be equal to f a b. Okay. Next, if you assume that the vertically acting force is positive and write a force equilibrium in the y direction, you will get f b c sin theta plus f a b sin theta, that will be, say this f a b c and f a b was equal to f. So, that should be equal to p, which will imply that 2 times f sin theta was p and f is p by 2 sin theta. So, you have found the member forces f a b and f b c from simple equilibrium equations. On the other hand, now say I add another member, here which is b d. Now, let us rewrite these equations. What we will have is the first equation, this is a 90 degree here, okay. The fx equation will remain the same for truss A B C D, sigma fx equal to 0 would imply that same as before, f b c minus f a b into cos theta must be equal to 0, but summation of the vertical forces would imply that f b c plus f a b sin theta plus f b d has to be equal to p, where this is f b d. Okay. So, now what happens? You have 3 unknowns and you have 2 equations. So, you cannot solve the 3 unknowns which are f b c, f a b and f b d using these 2 equations. These are linear equations. So, you can't solve for 3 unknowns using 2 equations. So, you need some additional constraint, and this is where you have to assume that the truss is deforming. In other words, if you apply a force P, this point B would move down here, right. So, you have to assume that this point moves down, and then you have to do a set of calculations based on that assumption. Hence, you have to assume the body is deformable and not as undeformed, not as a rigid body. Okay. So, this is why it is important to understand how to analyze bodies as deformable bodies. Okay. So, we saw what a deformable body is and what is mechanics.